Hello, friends. Good morning, good evening, wherever you are. Greetings from Pune, India. This is Gaurav, and today we are going to talk about another important topic which forms the fundamentals of this data building block series. We are going to talk about compute. Storage and compute are the two most important building blocks of a data infrastructure. In our last series, in the last video, we talked about storage, and in this series, this video, we are going to talk about compute. So if you remember from our first video, we spoke about different types of sources from where we can get the data, right? Right from structured data in tabular forms in CSVs, RDBMS to the semi-structured, unstructured logs, and the data sent by some of the IoT devices. Uh, we also looked at the various options we have for storage, right? The different cloud data warehouses, the data lakes, or even the Hadoop data lake, or some of the modern data stack, as in Snowflake and Databricks. All these are required to perform your analytics workloads on top of to extract the insights from data. So we looked at the sources, we looked at the target warehouses or the data lakes or the lakehouse. But how do you get data into these, right? And that is where the transform process or the compute process is required. Now, those who are familiar with the term ETL, extract, transform, load, uh, that is what we are going to talk about, and how compute is used to perform this kind of an ETL processing. ETL or ELT as well, right? Like some of the modern platforms, some of the warehouses, right? They are more towards performing ELT. ELT as in where you extract the data from these source systems, you load it into Snowflake, and then you do the transform within Snowflake as well, right? So so all the compute power, okay, that is required to transform this data, right? This data that you get from these sources, to ingest this data, to transform it, to clean it, to do the business transformations that are required, and then load it into these kind of a data storages, right? So what are the different compute options? And let's look at this one by one. I've formed groups of these so that it is easy to explain. The first is the Hadoop compute layer, I would say, or the services that Hadoop offers. Right? If you have used Hadoop, you would be aware of Hive. Hive has been used a lot to do the not just to store the data, but also to perform a lot of ETL kind of a stuff. Right? There is a query language, HQL, Hive query language, which has been used. And then Spark is the framework which is very popular. It gives you batch as well as streaming capabilities. You can use it for doing any kind of compute on this data. Most of the data engineers would be aware of Spark, and they must have used it a lot in any of their current programs. For streaming, Kafka offers a very good choice for getting the streaming messages into your system, into the data lake system. So this was all about the Hadoop components. Moving on, there are also ETL tools. There have been traditional ETL tools which a lot of enterprises have been using to ingest or extract data from the source systems and do the required transformations. Like Informatica has been, one of the players who have been there in the market for a long time. There was another one called Data Stage when I started in 2004. We worked on Data Stage. It was a product by Essential that time, and then I think IBM took over, and then it came up this whole WebSphere suite of products. Some of the new age ETL tools are also there, which are now gaining a lot of traction, like Fivetran and Airbyte. Uh, the main USP of these tools, I would say, is they come in with inbuilt connectors. You don't really have to create any custom connectors to, let's say, if you want to connect to the YouTube analytics, right? You want to get the data, or you want to connect to Twitter and get tweets from a particular thread or particular hashtag, right? They can directly connect to them. There are inbuilt connectors. They can also replicate the data from your source systems to your target. Let's say you have this RDBMS and you want to put the data into Redshift. So you can use Fivetran and connect to some of these source system, and it will start replicating the data, right? And it can be an ongoing replication. You don't have to really do the replication or do some customized connections for that. You can explore more these products. It does help in offering a lot of flexibility, and can help you in implementing a no code kind of a system for ingesting data from various data sources. Then we'll talk about the next set specific to various cloud providers like AWS, GCP, and Azure, and what offerings they have. Okay, so like AWS, right? They have four important services. I would suggest starting from Kinesis, EMR, Glue, and MSK. Okay, let's look at these one by one at a very high level. Just a quick definition of these. Kinesis can be used for your streaming data. Glue is used for all your ETL kind of a workloads. EMR is the Hadoop managed Hadoop buffering, and similarly, Kafka is the managed. MSK is the managed Kafka offering from AWS. All these data services can be used to ingest and transform the data into your data lake or a warehouse. When it comes to Google, it has couple of offerings called the data flow for real time as well as batch, and Dataproc is for your Hadoop and Spark offering. Similarly, Azure also has different set of services. ADF is for Azure Data Factory, is kind of an ETL and orchestration service to ingest the data. Then they have something called a HD Insight, which is for the Hadoop environment, and then the streaming analytics where you can stream the data. While we spoke about these three, main cloud providers, there is also a lot of traction in market for two products like Snowflake and Databricks. As we spoke about Snowflake already in a previous lecture, it is not just a data store, but you can do a lot of heavy compute using the Snowflake warehouse or the virtual warehouses. So if you are doing ELT kind of a process that we spoke earlier, you will first load the data into Snowflake store, and then you can write some queries, or in fact like a PL/SQL kind of a scripting within Snowflake to do the transformations. Now Databricks is something we have not spoken about earlier, but it is also one of the products which is widely being used, mainly because it can work with all the three clouds like Snowflake. It can work with AWS, GCP, as well as Azure, and it gives a lot of features for data processing, and it is built in Spark. This is a product built by the folks who created Spark. Um, you can use various features like having a optimized Spark engine. You can also use Spark SQL. They have some of the new products like Databricks SQL, which you can use directly to query the data which is on data lake. So yeah, it's another offering which you can use in fact for your Lakehouse architectures also, and we'll talk about that in a bit when we speak more about the Lakehouses. And finally, I'll quickly talk about DBT. That's another product which is also gaining a lot of traction. If you have ever heard about the term called analytics engineer, or these are the folks who are using DBT a lot. DBT is the data build tool. It is used for building your ELT kind of a framework within your cloud warehouses, like maybe Snowflake or Redshift, right? You can use DBT. It gives you a complete framework to have a modular approach, so that you can structure your code properly like a program, and it can give you restartability abilities as well. That brings us to the next topic, and that is related to the lake house, as I mentioned. So, if you remember from our yesterday's discussion, there are just a minute, yeah, there are there is another data store which is gaining a lot of traction. That is a lake house. Lakehouse gives you the features of a data lake as well as a warehouse. So it can use the cheaper data storage like the cloud object storage, and the same time it can give you the performance of a warehouse as well as the capabilities like acid, time travel, and others. So in market there are various again tools, compute tools, which are offering engine of our Lakehouse. Obviously, Databricks is one of the market leaders. They are the ones who coined this term called Lakehouse. You can use the Databricks SQL as a compute to extract the data which is within S3. Similarly, there are other products like Trino. Trino is nothing but your Presto SQL, if you have ever heard about that. And then there is another one called Dremio. They have also launched their cloud offering as well. So what is Dremio is again just a compute engine which can extract the data from your data lake. For data lake, I think they are using Apache Iceberg on top of the cloud object storages, and they have this computing engine which can offer a very blazing fast performance to get the data out of your lakehouse. So that was about lakehouse. And finally, Confluent is another platform. This is another group of categories. This is mainly from the streaming perspective. So far we mainly spoke about the batch data, where you are taking the data once in a day or micro batches. But when it comes to streaming, like we have Kafka or MSK, which is the managed offering of Kafka. Confluent is another platform which I've seen a lot of customers using. Confluent provides a complete platform for having a Kafka to connect to your source system to get the streaming data. It also provides the streaming analytics capabilities. It has various features like KSQL and all, which you can use to do some querying on your streaming data. So again, this is built by the like Databricks. Confluent is also created by or built by the creators of Kafka. You can definitely go and check this out. So yeah, these are all the various compute offerings which are there. If you're building a data modern data stack or modern data architecture, you'll keep on hearing about most of these. There might be few others which I have not spoken about, but these are the ones which are currently being used across various enterprises. Maybe you can go and check them out one by one and do a deep dive and explore them based on your use case. um, that's it for this lecture. We'll come back again for the next lecture. If you have liked the content, please do like and subscribe to my channel so that you can get a notification of another videos. Or you can also connect me on at Twitter or read about some of my articles on Medium. That's it for the day. Thank you for listening to me. Bye bye.